Okay, so we first dealt with the Bohr quantum model of the atom, and he set up the framework for a really good start, but didn't quite get everything correct. So, what is currently accepted as far as the electron configuration and the idea of how the shells are set up around the electron and the orbital clouds and things like that, we call it the modern quantum model. Okay, so Bohr's model doesn't work for everything. In fact, it really falls apart after you hit argon. And that's because really what's going on is something way more complex than just these concentric, here's a circle around the nucleus and here's another circle and here's another circle. There's crazier things going on. So, like the analogy to the apartment building, there's all of these different levels, and then even among the levels, there's sublevels. Okay, so all in all, there's a total of 7 total levels. All right, and then the apartments within each level, aka your sublevels, have different shapes, and that's how you can tell the apartments apart. Okay, so then what we've identified as the S level has considered a spherical shape. Okay, P levels have this kind of a dumbbell shape around the little gray thing in the center here is your nucleus. Okay, the D level has this, what they've called a flower shape. And then the F level is this double flower shape. Okay, don't worry about totally understanding the shapes and how they interact with each other and fit all together. Just recognize which shape goes with which level. You can tell as you go up, they get more complicated. Okay? Okay, so the first level has only S apartments, and it's only one S apartment, which is why you go 1s2, and then you immediately go into 2s. Okay? The second level contains your S and P apartments. So here we had the 1s2, this is the 2s2, and the 2p6. Sorry, my marker is not working. And then you continue up. Third level is you have S, P, and D apartments. Fourth level, you have S, P, D, and F apartments. So the fifth level contains S, P, D, and F. There is the potential as we make more elements that we may need this G level, but don't worry about that. Okay? And then the sixth level, as you continue, based on our current periodic table, it starts to drop back down. You have S, P, and F, and then right now the seventh level only has S and P. Okay? Now, of course, periodic table keeps getting bigger. This may change, or there may be a new modern quantum model. Okay? So again, just recognize the shape that goes with each letter. Recognize that they get more complicated, but the levels, you can spot them from those coefficients. The 1 in front of 1s2 tells you your level. The 2 in front of your p6 tells you your level. Okay? So, S apartments always occur in groups of 1, and within there you can have your 2 electrons. Okay, so each level can house 2 electrons. Each apartment. The P apartments occur in groups of 3. When you multiply that by 2, that means you can have 6 electrons in there. D apartments occur in groups of 5, which means you can get a total of 10 electrons in the Ds. And the F apartments occur in groups of 7, so you can have 14 total electrons in those. Okay? So just some people that were addressed in the packets we've been working on, and you want to make sure you know what their contributions to this model are. Pauli and his exclusion principle says that no 2 atoms in an electron can have the same address. What that means is that they have to have opposite spins. Okay? Really what this means is that the electrons, they're kind of like the Earth. the Earth has its axis that it spins around, okay, along with the sun that it rotates around, okay? Electrons have their own spins, plus they're rotating around the nucleus. And so if they're in the same orbital, they have to have opposite spins. There's the Aufbau principle that states that electrons fill the lowest available energy orbitals first. Okay, we've looked at this, but just to make sure that we're clear on what it tells you, the arrows go with increasing energy. All right, so if you kind of follow this first arrow, this end here is low energy. As you go down, it increases. And as you go across, energy increases. Okay. So you can see as you go through the levels, level 1, 2, 3, 4, it goes up as you go. But it gets a little funky when you go, especially as you get to your F's and D's. Okay, because those transition metals and the the lanthanides and the actinides down at the bottom are just funky. So we keep them on the periodic table where they are because of their atomic number, but their energy doesn't quite follow this easy pattern of, you go 1, 2, 3. Starts out that way. You go 1, 2s, 2p, 3s, and then you hit 3p, 4s, and then you go back to 3d. Okay? So 4s is slightly less energy than 3d. And then 4p, 5s, back to 5d, 5p, 6s, back to 4f, which is slightly more energy than 6s, but less than 5d, which is less than 6p. Okay? So the d's and the f's get a little funky. This chart, I will give you. I'll post a picture of it on your test, but make sure you know how to interpret it. Okay? So if you were to trace it down like I was just doing, you start here and you follow your arrows, it walks you through the order of the energy levels. Okay? So 1s is greater than energy than 2s, which is greater than energy in 2p, followed by 3s, and then you keep going and the energy increases. Okay? So Hund's rule states whenever possible, electrons spread out among equal energy levels. Okay, so think of it as like trying to balance the level out. So you want to spread your weight out as much as possible. All right, and that's just the whole idea that when you have 2p2, instead of pairing them up right away, you spread them out. And you'd continue 2p3 would go in here, and then you don't start doubling until you get to 2p4. Okay. So, some practice. Write out the orbital diagram for hydrogen, chlorine, and bromine. All right, so diagrams are going to be the boxes with the pictures of the arrows. So for hydrogen, it's pretty easy. You have your 1s box and 1 electron in there. Okay. Chlorine has 17 electrons. So a couple of different ways you can do this. You can show your levels in height. So we've got the 1s, 2s, 2p, kind of like the diagram had you going. And that's going to give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I need to go to 3s, 11, 12, and 3p. 13, 14, 15, 16, 17, and stop there. Or, like I'm going to do with bromine, I'm going to slide this up a little bit. You can do it, just left to right. So, bromine has 35 electrons, so this is going to go for a little while. We have our 1s, 1, 2. We have our 2s, 3, 4, 2p, 1, 2, 3. So we got 10 electrons there, 3s, that makes 12 electrons, my 3p, one. I know I'm going to fill this, so I'm not doing it in the right order. So that gets me up to 2, 4, 10, 12, 18 electrons. So my next energy level, if I'm following the Aufbau diagram, 2p, 3s, 3p goes to 4s. And I need 2 more there. And then from 4s, I go to 3d. And I can have 5 boxes here. And I know I'm going to fill all of those. Alright, these can be a little tedious. It's more one of those things, once you got it down, it goes very quickly. But if it's not making sense, make sure you do as much practice as you can before the test. And then lastly, for P, that's where I end. I'm going to have, I have 2, 4, 10, 12, 18, 20, 30, I need 5 in here. So fill my same direction first, and then opposite spin, and it's all filled in. Okay? So orbital diagrams take a little bit. Make sure, the tricky thing is to make sure that if, there's one that only has, say, 3 in the P, make sure that you have 1 arrow in each. All right? I'll probably make sure to pick out something like that when you have your test. Okay, so if something asks you for an electron configuration, that's the crazy code. All right? So instead of having to draw all the arrows, you can write it in this code, which to me will indicate the same thing as the picture. Okay, so make sure you're paying attention to what the question asks for. Diagram, you draw arrows. Configuration, you give me your code. Okay? So for example, say with bromine, what I could have done, and this probably would have gone a little faster, is I could have done 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then written in my last part being the 4p5. That would have been my bromine configuration. That was a lot faster than drawing the little arrows. Okay? So, just some things to keep in mind whenever you're doing these. Make sure you identify the total number of electrons in the atom. All right? Whenever you hit s orbital, you only have to include 1 pair. Whenever you hit a p orbital, you need to write 3 pairs. All right. D orbitals, 5 pairs. All right. So make sure that your numbers match up to the 2 electrons, 6 electrons, 10 electrons that each different sublevel can hold. So for a little bit of practice, try writing the electron configurations for these 4. Pause the video, get them down, and then I will write them out real quick so that you can see if you were right. So here's all the correct configurations. Not too bad until you get to uranium, and it's very long. I had to go back to another line. One quick question to you is this last part, the 5F7, since 7 is the halfway point of your F level, the arrows would all be, hopefully you say, pointing in the same direction. And there'd be 1 in each sublevel. Nothing's doubled up yet. If you had to, say, draw in a configuration. Or I could ask you to draw, say, the configuration at the end here. And you should be able to do that. one thing to help, especially when you get down to the end of the periodic table and some of our larger electron elements, is there's this condensed version of writing things. So we use the noble gases because they always represent a full level to shorten things a little bit. So for example, neon, whenever you have something that has at least 10 electrons, you can replace this part of their electron configuration with a bracketed neon. Okay, so for example, aluminum has the 1s2, the 2s2, the 2p6. We can get rid of that part, plug in neon, and then write the rest of it, the 3s2 and the 3p1. Makes it a little bit shorter, especially if you did something like uranium. Instead of writing that out, I could have done radon. Nope, not radon, xenon. The noble gas in the row above uranium, I could have written xenon, and then wrote the 7s2 and the 5f7. That would have been much shorter way of writing out uraniums. Okay? So, practice that a little bit with these. Pause the video, take care of them, and then I will post the answers in a second. So here's what those look like completed. Make sure you have notes for in class and do the online quiz.